Well, like she said, I'm Andrea DeMarsh, chemistry major, and this year I worked under the advising of Paul Edmondson, and we wanted to look at a new material as a possible active ingredient for deodorants. So this is all happening under the personal care industry, which is about a $40 billion industry that faces two challenges that we wanted to look at specifically. So the first one being that we wanted to see an extended release of fragrance. So I'm sure everyone's had the experience of putting on perfume and it smells really intense for the first 5 minutes and then rapidly declines after that. So we've seen that it actually is almost completely gone after just about 50 minutes. So we're looking at using this new material for prolonging that and then also absorbing malodors at the same time. So when I say malodors, that's body odor. And right now in the industry, one material that's being used is in Secret and Old Spice. And there's been studies that show that that only absorbs about 60% of malodors. So we want to try to increase that. We want to overcome these challenges with just one ingredient, and that would be Absorb. So a few of you may have heard of that. It was actually discovered here in Worcester during an IS project under Dr. Paul Edmondson. And it's a really unique material because it looks like a powder in its dry state, and that's actually the low energy, or the high energy state, sorry. So it wants to get to the low energy state, and that happens when it absorbs things. So it's really good at absorbing things, as you can imagine, and it absorbs everything but water. So therefore it's been used for water filtration and environmental processes, but now we want to look at it for the personal care industry. So the goals of my project were to see if Absorb could absorb malodors, and if it could, how much. And then secondly, we wanted to preload the fragrance, or the Absorb with a fragrance, and then see if it could still absorb those malodors while also kicking out the fragrance at a higher rate. So this would be useful, say, if you had this in your deodorant and you went to the gym, and when you start sweating and producing malodors, it would kick out the fragrance at a higher rate. So it would have this dual capacity. Our results showed above a 90% removal for 3 malodors that we tried, and up to a 99% removal, which is a pretty big jump. So then we decided to move on to preloading it with a fragrance that we chose, and we saw that it removed malodors even better when it was actually preloaded, and then also that it would kick out the fragrance at a higher rate, both of which we were looking for to happen. So in the future, we hope to see this actually being used in products, not only deodorant, but for perfume and dry shampoo, and I'm sure lots of other applications that we haven't even thought of yet. So look out for Absorb in your personal care products soon.
Questions for David? Virginia?
What did you use for the stand-in for the Malodor? What chemical did you use?
Good question.
So we used 3 different ones: 1-hexanol, p-creosol, and indol. Most of those were just kind of analogs to what actual sweat, what would comprise actual sweat. Yeah. So those were kind of just used as our 3 analogs that we looked at. Mm-hmm. Yeah.
What perfume did you use?
We used linalool. So the difference between what we use and perfume is that linalool is just one compound, whereas in perfume you have a bunch of different ones. So that would be kind of the next step, to look at complicating the system more and having an actual perfume being used. But that's being studied. Yeah.
Why would it work better if it was preloaded?
So it gets a little complicated, but basically because Absorb works through this elastic matrix, having it preloaded actually helps the malodors to be absorbed into the pores of it. So not any other materials that we know of has that capability, but Absorb, because it works through that expansion, the contraction, it can. Yeah.
I remember you saying that you wanted us to make something such that the more you sweated, essentially, the more perfume would be released. Mm-hmm. Was that the case after you loaded it with perfume?
Yeah, so what we saw was that when it was preloaded, it actually absorbed all the malodors. So we're hoping that actually means 100%, although it's probably just close to that. And then it kicked out the fragrance at a little bit higher of a rate. So it did do that, yes.
Dick?
How long does it last?
Well, we've done the calculations with just linalool, and it's a little bit surprising, but it looks like it would run out like completely. So this is not on a person. This is just in the hood in a lab. It looks like it will completely run out after 30 days. So that's not practical for a user, but what we want to see for a person is that it will last at least 24 hours, which we're confident that it does.
So you have a thing that makes you sweat flowers. What's the process of seeing that in products, like in my deodorant or something? Do you have like a thumbnail sketch of how that works for the big thing?
Yeah, so it's being, if I'm answering your question correctly, it's being looked at in some cosmetic companies right now. So we're really excited about that. And then, so they're going to run their own trials with it first, and then we'll see after that.